My name is Farni Weaver, and I am a technology strategist at Sprint, and working as a standards delegate at ETSI, specifically the ZSM project. And I also attend the 3GPP CT meetings. So Sprint is one of 14 original founding members of the ISG, the ZSM ISG. And I am here today to represent ETSI view of the ZSM ISG. There it is. All right. So there are 4 normative documents that drive the development of the ZSM framework. ZSM1 is it captures the use case scenario and business requirements, and the scenarios are documented as a collection of short stories of operators' challenges, and each scenario defines a set of business requirements. And it's very important, and as highlighted by Nurit, that even though it's a tedious task to collect business requirement, but it's very important so that we all have the same vision of what we want to achieve in ZSM. Now, ZSM2 is another normative document, and that is the architecture document, and it uses the requirements from ZSM1. ZSM2 defines the reference architecture and the architecture principle, and it also defines the management functions within the architecture, and also the high-level interaction patterns between the functions. Uwe will be going over that in a little bit after this presentation. ZSM3 defines the end-to-end management and orchestration of 5G network slicing. It uses the ZSM2 to generate the stage 2 version, a little bit more detail, I guess, of the architecture. And ZSM8 is the, just recently created as a response to operators' call for priority. And it's important that we have a good scope of what we want to achieve and deliver within the timeline. So that was really the reason for the ZSM8. And my presentation today is focusing on ZSM1, the business requirement. So this slide illustrates the approach we use to capture the requirements. Today, we have 65 members and participants in ZSM, and of which 19 of them, I think, are operators. And operators play a vital role in making sure that our business requirements are captured and prioritized accordingly, and also making sure that the architecture requirements align with our needs. So requirements are derived from operational challenges and industry visions, and as well as advanced technology being considered as well, which we do that a lot actually with the intelligence that's being applied or added to the ZSM framework. The goal here is to create a framework that supports a complete automation for managing a multi-vendor environment network, and that is future-proof and also standards-based and very flexible. So a little bit, just real quickly, about the status of ZSM1. There are 39 use cases, scenarios, that's contributions that's been accepted in ZSM1, which made up of almost 200 requirements. But since the scenarios are basically They were independently submitted and accepted. There were a few duplicated requirements that we found, and we've gone through and carefully cleaned up the list of 200 requirements, and we ended up with, and also clarified them and for readability, and we ended up with 159 requirements, business requirements, out of the 39 scenarios. We've reached stable draft March 6th, and the final draft is targeted in April 30th this year. So for the purpose of document readability, the business requirements and scenarios are categorized into the following groups. So we have the automation of end-to-end network and service management. This is at a high level, focuses on automation of end-to-end lifecycle management of network resources and services, from installing to commissioning to day 2 operation and decommissioning. And the next scenario is the end-to-end automation of 5G network slice management. It's basically the same group as the one previously, except with the addition of the 5G network slice requirements. Example of requirements there include the capability for ZSM to clone or scale the network slice instances. Analytics and machine learning. That is the grouping that related to analytics and AI, and I have more in the next slides for that. Same with automated testing. At a high level, that is this is about ZSM to automatically execute test procedures, and again, more on that later. The NAS life cycle and exposure with slicing. So an example of requirement here includes, for ZSM to support managing the life cycle of network capabilities exposed to external domains, and provide interface that hides the internal network details. So collaborative federated service management scenarios. So that is the grouping about supporting network management across operators. And an example requirement there would be allowing for advertisement and discovery of services across operators. And then we got security. A lot of the security requirements are actually documented in ZSM2, but an example of few security that's documented in ZSM1 include the capability for ZSM to troubleshoot encrypted traffic. So that would be like the business requirement on security. And then, of course, integration and interop scenarios. We have some list of requirements under that group, and that would be an example would be ability for ZSM to interwork with legacy systems. All right. So this is one of the scenario grouping, the end-to-end network and service management. So the scope of what ZSM is managing, or the managed resources, include the core, the RAN, transport, the cloud infrastructure, the NFVI, VNF, everything in between, basically all layers in the network that we manage, that can be managed, would be part of the scope of what is being managed by ZSM. So an end-to-end service is made up of basically several of these combination of network resources. In the picture here, the scope of managing the life cycle of network instance, for example, we got commissioning, which includes the deploy, install, and upgrade. And then we got activation, which is the configuration change. And then we got the day 2 operation, which includes monitoring, assurance, the troubleshooting, the remediation of that, and also decommissioning. Now, design is part of operator's task, but it is out of scope, at least for this phase of ZSM today. So in the deploy and install and upgrade, or the commissioning, just to give you an example of some of the requirements included there. For example, ZSM to check to make sure that there is enough resource capacity available during deployment of a service. That would be one example of a requirement. Another example is, for example, during the deployment, a service level SLA is being entered, and ZSM would take that input and generate the resource level KPI or metrics and assign that to the individual resources, the network elements, to be monitored. And another example is the automatic installation and upgrade of physical and virtualized network function. So I know as an operator, it is an issue today. For example, when you want to upgrade OpenStack, for example, and you have various multi-vendor VNFs running on top of that. And you want to, you think you're ready to upgrade OpenStack, but it's dependent on those VNFs to be certified on that new version of OpenStack. So, the hope, what we're hoping ZSM will do, and it's part of the requirement, is to check when everything that's dependent on the version, for example, is ready, then it should fire up the installation of the version accordingly. So that's just one example. With regards to monitoring and troubleshooting, the key or some of the requirements there, with the stringent ultra-low latency and ultra-reliability requirements of 5G, today operators are even more challenged to make sure that the day 2 operations of the network are managed efficiently and the network issues to be resolved quickly. So, today with the operation folks, with the having a hard time keeping up with all the emerging technologies, it shows up faster than they could learn it. So they need all the help they can get from ZSM. So in this, an example of a requirement would be, upon receiving a fault detection, when ZSM receives a fault detection from the network, for example, ZSM is to automatically perform troubleshooting by executing what we call, in the manual term, the playbook, right, of identifying root cause analysis. That playbook could be the workflow. And by possibly utilizing machine learning to add dynamic intelligence to the decision, and also perform remediation to fix the issue. So that's one example of where, the monitor and troubleshooting would be, a requirement in that scenario. Although we want, all of us want to have close loop automation, some operators also want the ability to intervene, right? Because first time you install it, you don't necessarily trust it, right? So they want the ability to intervene the automatic fix. They want to be able to review what the suggested changes are and either manually apply the change or let ZSM proceed with the change, or perhaps wanted to do their own change. So either way, right? So at least they have that option. And that's another requirement. Even though the target is closed loop, we want that configuration ability to be there. Okay. Where are we at? So this is the grouping for analytics and machine learning. So to achieve zero-touch management, the framework must be intelligent, right? So there are about 43 requirements that are grouped under the analytics and machine learning scenarios. And this is one example where I mentioned earlier the advanced technology is being considered, right? And here it's not necessarily you would call a business feature requirement, but it's a because the technology is there, we want to take advantage of it, definitely. So in real-time monitoring analysis, for example, so this is analytics based on policy or parameter setting, either configurable during deployment, or it could be subscribe and dynamic. Machine learning. So there's a lot of application for machine learning, right? For example, we may want to optimize the network, and it's based on the historical data and maybe the time and whatever, or whatever other condition there is. The ZSM will figure out, hey, I need to optimize it. I need to maybe reroute it and do something about it. Closed loop automation. I have a slide to talk about that next. Access to telemetry data. So data would be stored in, we'll talk about that a little bit later, in a common data, basically in a big data for analytics and machine learning purposes. Predictive analytics. This is examples there would be requirements for capacity planning. So today, operators, we all have to budget our hardware. I mean, hardware, it could be a few months of, to acquire it. And you want to be able to correctly predict when you're going to need new ones. And CI/CD for ZSM framework. That is basically allowing for automated development integration to the ZSM. Let me make sure. All right. So this is an example of, I have a diagram of the closed loop automation here. In the very top box there, object of automation, that's really basically the managed resources or the network elements or whatever you're managing. Monitoring, so when an anomaly is detected, a trap or whatever, the monitoring assurance function would then be notified. And we have data collection function that would perform that function there. And then it would go to orientation, where the analytics, with the help from maybe inquiring the policy, the topology, or maybe some AI, the log, whatever it needs to do, and would perform troubleshooting and determine the root cause analysis. And then a recommendation from analytics would be sent over to the decision box, and that would be could be the orchestration that Uwe would be talking about later. And based on the policy, a decision is made and then would be sent potentially to execution, and that could be the control function. And the execution could be things like a change configuration in the router, as simple as that. And the loop will then continue while the issue persists. Hopefully it will get fixed the first time around. But if it continues, it's gonna loop around. In the decision block there, I mentioned earlier about the capability for operator to intervene. So, and that's the box where potentially we want to be able to pause right there and decide whether we want ZSM to proceed, or whether we want an individual to go in and manually make the change, or whether we don't, we want something else to happen. So, all right. This is another grouping scenarios for automated testing. I only showed like 3 groupings here because those are the top 3 that has the most requirements, I guess, out of the 159 requirements. This one had about, I think, 19 requirements under this. An example there where this would be used is during deployment of an end-to-end service, for example. You ask, operator may ask to deploy an end-to-end service, and after everything is installed, all the impacted network resources, we want to ZSM to potentially perform a unit testing, and then if that is successful, perform connectivity testing in between the different resources, between the P gateway and the PCRF, for example. And then interrupt testing to make sure that it comply with the standard, that it can actually talk to each other using whatever protocol you're supposed to be talking to each other about. And then in the end, automatically, when everything is successful, an end-to-end testing could be done. So that's the vision of this, what we think we want the automated testing is for. It could also be used in during troubleshooting, right? When you make the change and you want to test it. So that could also be done there. So I'm in the conclusion slide here. So we talk about the value of ZSM1, the business requirements, how it fed into the ZSM2 for architecture, and then so on with more detail in ZSM3 and ZSM8. Those are the 4 normative documents. I know Nurit listed more than that, but some of them are more informative documents. And I've also outlined some of the key requirements and kind of give you an idea of what ZSM is trying to achieve, right? And then one of the next steps that we're doing in the ZSM1 realm is to identify about the top 1 to 3 interesting or relevant scenarios out of the 159, and so we can handle them in more detail and possibly use those as an example by using the detailed services that's defined in ZSM2 to make sure that all the interfaces of the high-level services, resource services interface are captured, at least could handle those top 3 scenarios. And that would allow us to identify if there's any gaps and missing requirements there. And also to derive proof of concept. So we, as Nurit mentioned about proof of concept, we have one that's completed and one that is being reviewed, and we would like to invite whoever, more participation in proof of concept. So I think we got one topic today that's active, which is automation in multi-stakeholder ecosystem. But we would love to see one where it uses the ZSM2 reference architecture. And here are the links of where you can get some of the drafts. And any question? Thank you. Yes.
That's all right. Okay. First of all, thank you very much for a very nice presentation. Okay.
You're welcome.
Thank you very much. Thank you very much for a very nice presentation. So I had a couple of questions related to the analytics and machine learning grouping. The first one is, do you guys at ETSI are getting to the point of specifically selecting or assessing which type of algorithms or techniques, machine learning techniques, are going to be used in the scenarios that you have identified as requirements to be able to realize what the ZSM is going to do in this regard?
So we have the means of automation document. I think it's ZSM 5, ZSM 5, which is informative. And there we talk a lot about all the different automation, and I think that is also part of that. I'll have to, Andreas is going to be covering that piece later on. I'm not sure if that's all part of that. But in ZSM2, nothing specific yet, I don't think, but no. But we will. We have at a high level, we have a function, intelligent function, and the plan is to have machine learning there.
Yeah, definitely. I mean, I think it's really interesting if you, I mean, because at the moment, I mean, okay, we know we need to perform, let's say, anomaly detection or something. There are so many ways to perform anomaly detection, so those are going to be different based on the type of use case or the type of maybe the data that is generated by the network or something like that, right? So that's, I'm not sure if maybe you're going to get to that point, but maybe, I mean, some guidelines for maybe the vendors to be able to realize these things and know what to do or what to investigate. That would be really good if we can have those at least, I don't know, documented somewhere, so we can have a more clear direction on the.
Yeah, that's a good feedback. Yeah, maybe we can discuss that offline.
So my last question very quickly about the OSM role into this, the open source Mano. I mean, I see that there were some, I mean, the specific one related to the analytics as well, like, you know, the closed loop automation and stuff like that. You mentioned that maybe the orchestrator is actually going to be the one, I don't know, applying an action in there. Can I say, for the sake of understanding where all these pieces tie together, that that's going to be potentially the OSM or some other orchestrator or something? Is that where the industry is actually going? Thank you.
Go ahead.
So definitely, OSM can provide part of the solutions, maybe even a management domain, or maybe even just the orchestration, the controller, maybe the data collection. So there are multiple ways how to integrate into the architecture. One of the things that is essential to enable that, it's the modularity. Okay, and if they want to participate in the end-to-end solution, they need to expose their service capabilities that can be used to enable and Uwe will talk more about this integration fabric and the modularization, so to allow them to integrate in the end-to-end solution. Yeah, maybe just one comment regarding your question about ML, and I definitely see a lot of value, and I second Farni with her comment and reply. In general, specification is intended to enable that, you don't specify the algorithms. This is where you differentiate. This is where you provide your value. But you need to ensure that it is enabled by the specification and can work in multi-vendor environment. This is the role. This is the intention, interoperability. But I think it would be very, very valuable to learn more about this and maybe even to publish some reports or even ETSI white papers that can show the different options and the selection criteria, etc. Great.
Thank you.
Thank you, Farni.